Hi everybody, so we're going to be talking about two problems in this video. The first is this one about elapsed time, and the second is this one about converting meters into millimeters. So let's get started with this word problem. Let's read first. If Grayson's team played a game of baseball that lasted for 2 hours and 15 minutes and the game ended at 5:30, what time did the game start? So what I like to do is to start by writing my S for start, E for end time, and E for elapsed time. I always put this first E as the end time, so it's related immediately to that start time, and the second E for the elapsed time, the time that has passed. So we know that the game ended at 5:30. So under this first E, I'm going to put 5:30. And I'd like for you guys to follow along with me in your math notebook while you're doing this problem. We do not know what time the game started because that's what the question is asking us. What time did the game start? So we'll need to find S here. We do know, however, the time that has elapsed, and that's that 2 hours and 15 minutes. So I'm going to write 2 hours, and I'm going to abbreviate HR, and 15 min for minutes, my abbreviation for minutes. Alright, so in order to find this start time, I have my end time, so I need to go backwards in time. And the easiest way for me to do this is to use that number line. So I want you guys to go ahead and draw yourself a number line. And at the end of our number line, we're just going to put 5:30. We're going to go to 5:30. And then we're going to go backwards in time by a half hour each little tick on our number line. So I'm going to give myself some space. Half an hour before 5:30 would be 5 o'clock on the dot. Half an hour before that would be 4:30. Half an hour before that would be 4 o'clock on the dot. Half an hour before that would be 3:30. Half an hour before that would be 3 o'clock. And let's go one more half hour. Just give myself plenty of room on my number line to 2:30. Alright, so I've got my end time here. I'm going to put a star here to show that that is my end time, 5:30. And I need to go backwards on this number line 2 hours and 15 minutes. So we could really choose either one. When I'm going from end time backwards to the start time, I like to start with the minutes first, because if I have to go past an hour point, it's going to be easier for me to do that when I still have my hours to regroup from. So let's look at 15 minutes before 5:30. Well, I know that 30 minus 15 is 15, so I'm just going to jump back 15 minutes. And I'm going to mark that above my jump on the number line. So 15 minutes before that would bring me into that 15-minute mark of the 5th hour, otherwise known as 5:15. So now that I've used up my minutes, I can go back 2 hours. Let's go 1 hour at a time. So remember, each of these is a half hour mark. So we're going to go past the 5 o'clock, past the 4:30. We're going to go back an hour between 4 o'clock and 4:30, just like how my current spot is between 5 o'clock and 5:30. I'm going to go back an hour, so I need to be between 4 o'clock and 4:30. And that's my first hour jump. And I know that this spot should have the same minutes in it, because we only went back an hour. We didn't change any minutes. We only went back 1 hour. So 1 hour from 5 o'clock would be 4 o'clock, and my minutes are going to stay the same, so it should be 4:15 at this point on my number line. Now I still need to go back 1 more hour, so let's do that. Again, I'm here between 4 o'clock and 4:30, so I need to go back an hour and be between 3 o'clock and 3:30. So let's make that jump all the way over here. That's another hour. We've gone back in time. Again, my minutes are staying the same because I only changed the hour. 15 minutes. And we are after the 3 o'clock hour at this point in our number line. So it is 3:15. So now I've used my 15 minutes and I've used my 2 hours. So I've got no more elapsed time to use to move on my number line, which must mean that this last point that I made on my number line is my start time. And I'm going to put that under the S, 3:15. So let's go back over the question. Now that we've done all this math, let's go back over the question and make sure that we understand what we did and make sure that it's correct. If Grayson's team played a game of baseball that lasted for 2 hours and 15 minutes and the game ended at 5:30, what time did the game start? So again, we have our end time, 5:30. We put that under E. We're looking for the time the game started, and we're thinking that's 3:15. And the game lasted 2 hours and 15 minutes, which we had under our elapsed time and made sure to utilize on our number line. 15 minutes back, 1 hour, second hour, a total of 2 hours and 15 minutes backwards in time because we had to work from our end time backwards to our start time. So that makes the most sense to me. We can double check by taking away our minutes. 30 minus 15 is 15. 5 minus 2 is 3. So this is making sense to me. I think that this answer is the best answer. So I'm going to go ahead and move on to my next question. So my next question says, Cody knows that the door of his clubhouse needs to be 1.4 meters wide. That's our first piece of math information. But his meter stick only shows millimeters. Well, it's going to be hard to find out how far he needs to move or how far he needs to measure if he needs meters, but it only shows millimeters. So what can we do? Well, we can convert what he needs in meters into millimeters to use that meter stick that only shows millimeters. So let's think about this. What would 1.4 or 1 4/10 meters be equivalent to or equal in value to in millimeters? So that's what our question wants us to find. 1 4/10 millimeters converted into some number of millimeters. And I think I might have misspoke. I meant to say 1 4/10 meters, and we're converting that into some number of millimeters. So the first thing I always think about is which direction do I want to go? If I remember my staircase, I know that meters is my base unit, and going from my base unit down one step takes me to decimeters, like we think of decimals. That's our first decimal. We go down again, that takes us to centimeters. Remember, centi means 100, right? Like a penny is 100th of a dollar. It takes 100 pennies to make $1. It takes 100 centimeters to make 1 meter. We got one more stair that we need to go down to millimeters. So because I'm going down the staircase, I know I need to move my decimal to the right. Well, how many places am I going to move that decimal to the right? That's how many times I need to go down the staircase. So if I'm starting at meters, I'm going to go down the staircase 1 time, 2 times, 3 times. So that's 10 times each time. And some of us get a little mixed up sometimes. That doesn't mean that we're multiplying it by 30. It means we're multiplying it by 10, and then we're multiplying that by 10, and then we're multiplying that by 10. Or an easier way to do it is to think of it as jumping 3 times. So we're multiplying it by 1, 2, 3 zeros after that 1, making it 1,000 times. So for each 0 that we see in that 1, 10, 100, 1,000, whatever it may be, that's how many times we're going to move over that decimal. A little trick for you guys. So let's take our 1 4/10, and let's take this decimal. I'm going to change the color to make it a little more obvious what we're doing here. We're going to take that decimal and we're going to move it over 1, 2, 3 times and place it right here. But what about these empty spaces that we jumped? Well, we know that there's a special digit that we can use to show that a place has no value. And we know that that digit is 0. So, let's think back to our question. What would 1.4 or 1 4/10 meters be equivalent to in millimeters? Well, if we move our decimal 1, 2, 3 spots over, because we're multiplying by 1,000, we're moving down the staircase 1, 2, 3 times to the right, we're going to have a value of 1,400 or 1,400 millimeters. And we're going to make sure to put that comma between the thousands place and the hundreds place. That makes it a lot easier for us to read this value. So there you have it. And we can double check to make sure that this measurement is correct, and I'm going to tell you how. 1 4/10 meters is equal to 1,400 or 1,400 millimeters. This makes sense because millimeters is much smaller than meters. In fact, it's 1,000 times smaller. We just talked about that over here with our staircase. So, because it's much smaller for each millimeter, we have to go a lot farther to get to the meters. So it makes sense that we would have a bigger number with our smaller unit and a smaller number with our bigger unit. And that's going to be true with all our metric conversions. The smaller number is always going to go with the bigger unit. The bigger unit is always going to go with the smaller unit. Sorry, the bigger number is always going to go with the smaller unit. I'm not sure if I said that correctly. I think I did. Definitely said it correctly the second time. So go ahead and answer these in your Pear Deck. You had 2 slides, one for each of these questions. If you need to go back through the video and review, awesome, do it. If you didn't write these in your notebooks, I highly, highly, highly suggest writing it in your notebook so that you are ready and that you can use those notes to help you in the future. Thanks for joining me, guys.